Hello and welcome to this channel. Today we are going to discuss about instrumental variable. In the last video we had discussed what is endogeneity problem, and today we are going to discuss one idea to handle endogeneity, which is instrumental variable. So we will discuss when to use it and what are its two assumptions, and I will explain one example of using IV. Let's just start. It is given here one OLS. This equation, this model is return to education model, which says that if a person has the idea is if a person has higher years of education, he will earn more, right? So earning depends on education. So when we will be able to estimate beta 1 consistently if the education is not correlated with error term. If these two are not correlated, then we will be able to estimate this beta 1 consistently. Okay, so but in this error term there might be ability of a person. Let's say, can we measure ability of a person? But let's not think proxy, like we can measure ability using IQ score, something like that. We are not talking about proxy here. Okay, so are we able to measure ability? The answer is no. That's why there is some correlation between this education and error term, because higher the ability, higher the error of education, right? That's why if you want to know more about endogeneity problem, I had explained in another video, previous video, you can check it. So what if this condition doesn't satisfy? If this condition or assumption does not satisfy, then that education variable will become endogenous, right? So if the correlation exists, it will be this education variable will be endogenous. Means if we are not able to measure ability, this ability always remains in this error term, then this error term and education will be correlated. So we cannot estimate this beta 1 consistently, right? That's why we need to use other methods, and one of that is IV. While using IV, we are searching for one variable that satisfies these two conditions. One is that IV should not be correlated with error term. Again, this IV should be uncorrelated with the error term, right? If we search one, let's say one IV here, that should not be correlated to the error term. Okay, and next one is IV and endogenous, means here education. IB and endogenous variables should be correlated. They both should be correlated to each other, right? These two assumptions should be satisfied before confirming IB. So in this example, let's talk about distance to home school, from home to school. Here are persons, individuals' home, and here is school, right? We are measuring distance from home to school. The idea here is that why we are picking this distance is that distance is not correlated with the error term, which satisfies the exclusion restriction. How? We cannot show it. We cannot show it by data because we cannot measure the error term. So if we are unable to measure error term, that's why, because we are unable to measure error term, that's why education is endogenous, right? So we are searching for another variable to treat as instrumental variable, and that should not be correlated with error term. Means we are unable to measure error term, so we can test whether this IV distance is correlated or uncorrelated. So how can we show? We can show by our argument. Argument will be like this: if ability is embedded within this error term, then we can say that, can ability of a person determine how far his home will be from the school? No. People start to live somewhere they want, and after that, if the school is built or the school is there, that is the fixed distance for all of the time, right? That's why this ability and distance doesn't uh, doesn't relate to each other, or one another cannot determine one another. Okay, so that's why this one we can say that We can argue that, even though we can show, we can argue that distance and error term is not correlated. So how about education and distance? The next one is relevance, which is another assumption. IV and endogenous means education in this case should be correlated. So we can show it by regress in education on distance. We can show it. There is another like t-test, or if there is multiple IVs, we can even test f-test. So we will talk those things later, but we can show it because we have data of education and we will have data for distance. So we can show whether they are correlated or not. If distance is if education is depend on distance or not, so we can test it statistically, right? So if that exists, if that those both satisfies, then distance will be a valid IV here. So even though without testing, why did we pick distance? Because we can say that a person who is closer to school, he will have more impact of the school, and he will definitely earn higher year of education compared to those who are far from the school. That is our idea before determining this distance as an IV, right? So one more thing, when we estimate this beta 1, it is not average treatment effect, as we say. Okay, so I had not explained ATE here in before in earlier videos, but ATE is if we compare total population. In total population, it is called average treatment effect. But this beta 1 will not be ATE, will not be average treatment effect. It will be local average treatment effect, right? Because this cannot be generalized in all population. We can just say that this IV is valid only for the compliers. If there is always taker or never taker, there are three categories. So it won't consider this always taker and never taker. That's why it only care about compliers. That's why it is not average treatment effect. It is only local average treatment effect. What does it mean? Compliers means let's focus on the relationship between education and distance. If we look at here, we are arguing that those who are closer to school will have higher years of education, and those who are far from school, they will have lesser years of education. But what if a person who is far from the school but has higher year of education? That is always taker. Doesn't matter whether he is closer or far, he will definitely have higher years of education. But how about one who is very very close to the school but does not have, like, even have no education, for example? Means doesn't matter, even he or she is close to school or far to school, he won't have any education, means he is never taker. So this model does not account is to these two categories, always taker and never taker. That's why we can say this is local average treatment effect, which is only care about the compliers. So we were able to cut the correlation between education and error term, because we are going through distance, which is not correlated to the error term but correlated to the education. So this is very helpful to run this model to estimate the local average treatment effect. We can say that this beta 1 will be the impact of years of education on the earning. Okay, so I hope this is introductory video about instrumental variable. In later videos, we will discuss how to use instrumental variable in multiple linear regression model, or I will upload videos about using it in Stata also. So please do like, comment, and subscribe this channel. Thank you very much.